So let me begin by so you can find more kiln here in Rwanda like this one. But Scat try to change this kind of kiln.
For what reason?
Because after they used wood. Kiln was built to use only wood, so they can use other fuel like sawdust, like peat and others. That's why we put some walls here.
So this is the changed one?
Yes, changed one. Because I think that I can find something. Let me show you something. This one. So before we had this kind of kiln. So they used wood because there was not what's here. But now Scat changed the form of the kiln, and now we have this kind of kiln. So they can use now. They can't use wood, but they can use the sawdust, peat, and others fuel. You know, you see?
How much less do you need to burn with different kind of fuels?
How much?
Like with wood, how many days does it take? And with peat or sand, sawdust, how long?
With sawdust, we can take. If you take much days, it will be only 2 days.
2.
Yes.
Is that with wood?
With wood, it's more than 3.
More than 3.
3 days. Yeah. Even if you go to the villages, you can see they take more than even 6 days to burn
wood,
bricks.
yeah.
Yeah, with wood. That's why with this kind of kiln, I think that it can be more better, and I think that economically it can be a good kind of kiln. So this is one of type of kiln. So we can have more than 3 chambers. But this is only an example, because here in Rwanda we have someone who have a climbing kiln with 5 chambers, and we have another one who have a kiln with 2 chambers, and another one who have only 1 chamber. Yes, so it depends upon your money, yeah, and your capacity of production. If you have good machines, you can produce more bricks.
And you need more.
You need more a big kiln. Yeah. So this is one of type of kiln. So if you go there, you can find others like VSBK, vertical shaft kiln. In Great Lakes we have only one.
Of these?
Yeah. At Nyange, in Rwanda, Ngororero. If for us to train people, to train manpower, how to use
Where do you put the bricks?
We put the bricks here.
So there are little space.
Yes, here. So after that, the bricks goes down.
Ah.
And here we can every time after 3 hours we can remove the bricks. But here we put other bricks, so it's
it's cycle.
But it's the cheapest kiln. Also, with 10 million Rwandan francs, you can have it.
And that one?
That one is depend upon the chambers.
Yeah, with 3 chambers, how much is it?
I think it's 8 to 10 million. Yeah. Yes.
This instead?
When I speak about cheapest, it depends upon other kind of kiln. Don't think about our capacity of money. So this one is what we call Ugandan kiln. I saw only one. one Ugandan kiln in Rwanda. And another one I saw it in DRC. But in Uganda we have many Ugandan kiln. That's why we call it Ugandan kiln, because it's a type of many kilns in Uganda.
So you fill this chamber with the bricks and then you fill with the fuel here?
Yeah.
And the smoke goes out?
The smoke goes out with the chimney. But we have also what we call ventilator here. Yeah.
So you can open this and you have more ventilation?
Yes. But this kind of kiln, to have it, you must have 20 million.
Where is it found in Rwanda?
Nyamagabe. I think Nyamagabe, Muhanga. Yes. Between the two places. Nyamagabe, Changwa, Muhanga.
Did you talk about this?
So I know that.
Before we got that one, where do we put fire?
You see?
Fire from these holes.
Yes. Fuel here, but fire we can put inside at the beginning. But fuel can put here, so we can have more fire, more fires. So after this kind of killing, we have the big one.
But before,
The most
about this one, the middle one.
is the middle one?
Yes.
Yeah.
See, there is a side.
Yeah, side one, yes.
It means that in one chamber there is.
We have only one chamber here. Sorry, here we have a machine. I think that I have a video there, I will show you. So here, every time there is something, you can take 6 lines of bricks and you go up. It's like a plate of iron plates. So we use it to put to remove bricks, and then we put other bricks up. You understand?
Yeah, maybe if you have a video, it's more clear.
I think let me finish this one. So here we have also zigzag kiln. In Rwanda we have one zigzag kiln. It's Ramagana. Ramagana. I don't know the place again. No, I don't know the place very well. But it's near Catholics. I don't know. Huh?
Kayonza or Gama?
Ramagana.
Gama.
Yes, it's Ramagana. No. Oh yeah. I think it's fine. For this one also, it's a continuous kiln, firing kiln. So here is the biggest one. To have this one, you must have more than 100 million. But we can build it. We can build only 2 chambers, and after that you can add 2 others, and after that you can add 4 others. So it depends upon your capacity economy. So here we have a cycle also, firing. We have 8 chambers. So this, if you see this one is 1, 2, 3, 4, 5, 6, and 8 chambers. So first of all, you can put bricks in all chambers, and then you can burn the first chamber. But the first chamber will also give some fire to the second one. Then when bricks in the first chamber are well fired, you can close the first chambers, and then you open the third one or the fourth one, but more activities in the second chambers. Do you understand? No. I think that you go to Mamagana, you see it. So it's like this. So here we have something like this one. What you call in French van. Yeah. So you put your bricks in all chambers.
Yes.
So you can begin by first chamber for firing, and then when you are firing the first chambers, there is some energy, there is some small energy which can go to the other chambers, and then you make what you say précuisson.
That French is beyond.
Is to prepare the firing of other chambers. So for other chambers, we not take much time to fire bricks, because there was some energy which was extending in other chambers.
It's to make it more efficient, basically. You use to burn a little amount of bricks already. You have a lot of energy going, spreading.
Yes, and you use less fuel to burn bricks. So here you are doing the firing in this chamber. All those chambers are open. Or it depends upon your cycle of firing. Because if you want to refroidir, to cool down this chamber, you must close this chamber, so energy will not go inside. So here this chamber, when this chamber is bricks in this chamber are well firing, you can open, you can then you can continue with the next chambers, and every day you do like that.
So you put the bricks
So I put the bricks here,
and you don't close.
and I open all of these vans.
Okay.
So these chambers, I put fuel here. You understand? But fuel which I put fuel produce energy, but energy will go through all chambers, because we have you see. And then when these chambers, the bricks in this chamber are well bent, you can close it, so you can cool down the bricks in this chamber, and you continue with the second one, and every day you do. If you finish with the second, the third one, fourth one, and you continue. You see? And yes, but when you put you remove the bricks in this chamber, you can put green bricks.
Green?
Yes, yes, which are not burned. Yeah. So you remove the bricks here, you put other ones. It means that
If you start by the middle one,
you say
if you start by the middle one,
you want to start by the middle one. No problem.
So
You can start
the
with.
fuel will be distributed to this side and this one.
I think
No,
it is more than
you can open this vans. You can close, please. You can close. If you close the vans, it means that energy will not go through.
No oxygen.
Yes.
You talked about my question
Yeah.
a bit about how do you cool down the chamber? Is it
Chamber. Only you stop to put fuel inside.
and then you wait?
Yes. And you close. It means that there is no transfer of energy. Yeah. If you close this one, it means that there is no energy which can get inside. So the chamber will, the bricks will cool down.
But here, you close here.
Not here. Yes, before when you put bricks, you close. Yeah. When you put bricks, you close this doors.
Yes.
Yeah. That is. So this also is a continuous firing kiln.
use on the pit and soda.
Yes.
Fuel.
For us, if you want to use wood, Scott said, "Oh no, it can't support you." Yeah. If you want to use wood, it can't support you. Yeah. Because it's an environmental project. No wood, okay. No children, okay. Yeah. many women. Okay. You see? Scale. With this one, I think that here we can have on the side we can have, I think, more than 20 or 15 meters. 15 meters. How many bricks? It depends upon your kilo. If you have a big one, it means that you can have much bricks.
Like this one.
Like this.
This one is only a sample.
Question. That is not on the scale.
You say?
It is on the scale.
On the scale. Not on the scale. I mean, it's not on the scale.
Okay.
Yeah. Because if you want to build a big one, you can build it. But I think if you will have time, I think that opportunity you can go and visit also our zigzag kiln. I don't have dimensions in my head, but I think that you can have dimension if you visit the site. Yeah.
Question. How do people who are inside get right? Where are inside? Inside. Yeah, where are planning the bricks before burning?
Before burning?
Yeah.
Sorry.
The problem of right, where they're inside planning the green bricks before.
So when you are cooling down this chamber, it means that you will remove bricks when the temperature will be less than 40 degrees. It means that 30 degrees you can get in also.
The problem of light.
Light.
While you are inside.
You can use anything for light, torch and others. Yes.
I thought that you have the brick that goes in. Maybe you put on bricks, you slide it.
No,
humankind they can.
So someone will be inside to arrange bricks. Yeah. Yes. So let us double VSBK.
The vertical one.
VSBK. That kind of kiln. Vertical shaft bricks kiln. So we show you how to build it. Yeah. Not chimney, the kiln. Yeah. So you see here is this kind of tools which remove bricks. So here it's go inside, it's go up, and then we take bricks out. Yeah. They put bricks and fuel here. You see fuel? Yeah. So it's up the kiln. Yeah. Now the roof. So is the fairing. You see here bricks are well fired. And then you see because we have the same fuel, the same clay, and we have also a thermometer. to test the temperature. Yeah. You see? So they put out, and then bricks goes down, and then they put again iron, and then bricks are removed. You see? And up they put other bricks. Yeah. So that is a system of firing. VSBK burn bricks. Yes, more, yes. But we have also chimney, that kind of chimney. Yeah. I think it's good. Thermometric test, like to know the proportion of clay, sand, and limon. Lime. No, limon. Yeah. Between clay and sand. Silt, yes. Yeah. So we have a test. This kind of test is to know the rate of silt, clay, and sand in the clay. Because for us, we don't need graves in the sand. We need only clay and sand, silt and sand in the clay. So if we know the proportion of clay, silt and sand in this clay, we can know what will be the quality of the bricks after done. You understand? But it's not only that. Also, geological characteristics. We must know also geological characteristics, because we can have a soil which contains much clay, but it's not a good soil for bricks. Because a good soil for bricks must have also a good plasticity. So we must have clay, sand, but we must know also the plasticity of soil, the shrinkage of soil, and other characteristics like plasticity, shrinkage, granulometric characteristics, and I think it's only that we can know. But and if you want to go, you want to know more than that characteristic, you can also use geological or chemistry. Because last time one of entrepreneurs asked me a question about colors of bricks. I have a site, but I want to have white bricks. How can I have it? White bricks.
Yeah.
Like this
one. So to have white bricks, it depends upon the quality of minerals we have in your soil. For example, in this kind of soil, we have kaolin. Kaolin. If you have a soil which contains also lime, we can have also a white brick. But if you have a soil which contains much iron, you have a red brick or a yellow. So the color of bricks depend upon the mineralogical constitute of bricks. So this is one of the tests we do here. So we begin by tamisage, to tamiser in English. Yes. So for small particles, we use this kind of test. But for others, particular for les particules grossières, comme on appelle ça.
Big particles.
Big particles, we use that kind of tools. Tami, there. Sieves. Yeah, we use sieves to know the proportion of sand in the soil. Because these tools You can use it for only soil under 80 micrometer diameter. Yes. More than 80, we use sieves to know the proportion of sand. But every time before we take only 50 grams of sample, and then we can make tamisage humide. Dry, yeah. Humide. So we use sieves with water. Yes, sieving, but we use we do it with water. Bricks, small bricks, with our small machine, small extruder. That is a small extruder. And then we can put some marks here. Marks. Then you see? What? Here.
Marks.
Yeah. Yeah, you see? This. So it's for shrinkage measurement. Shrinkage measurement. So after forming this kind of bricks, we put this kind of marks. After drying, it means that before firing, we must have measurement of this marks. And after firing, we must have also measurement. It means that we have drying shrinkage and firing shrinkage. And if you add the two shrinkage, you will have the total shrinkage.
Yes.
So this kind of test is to help us to know if you want to have a bricks of 21 centimeters, you must have a mold of 22.6 or 23 centimeters. That is the rule of this test. So after that, also we use this test. Also, we must put our bricks in the kiln. So we can go to the kiln. So we have your soil. You can mix with small water, or you can dry it a bit. Because you must control also your water rate in your soil. Because if you have much water, you will not have good bricks. If you have also less water, you will not have good bricks. So you must have a good proportion of water to have a good bricks. So you have your soil, which contains water, good proportion of water. You put it inside this machine. Inside this one, you see, and then I think that it's okay, no problem. And then with this kind of tool, you can push your clay to the form, and when you have your brick, you can cut it without any problem. And to push it, it's only to do that like this one. Huh?
And it's extruded here. You see there is a shape of that.
Yes.
The small ones.
I think I can do it. Yeah. So the brick can be removed by here, and we can have it.
Is that what is powder?
Okay. This is not powder. This is clay. We have clay and shamot. Shamot in English. What's it mean? Shamot in English. It means that you burn bricks, and then you can make powder with bricks. Yes, brick powder. That is shamot. So this is only for test also. This is cowling.
But is it burnt or you just mine it?
This
Cowling?
Yeah,
not burnt.
it's not.
But after that, if you want, you mix cowling with shamot and a small clay. You can burn it and have this kind of mix. That's what one, which we call special bricks, refractory bricks.
Yeah, because you use it for stoves.
Yeah, to cook, yes. It's the bricks which we use to build the kiln. Yeah. Because this kind of bricks resist to high temperature. You can go up to even to 1,500 degrees. Yes. And it's because of this kind of product, cowling. Yeah. So if you have bricks which can resist to temperature, you must use cowling. Also, cowling, if you mix cowling with your clay, you can have also strong brick.
What is the difference between cowling and ingwa?
And ingwa is
Lime.
the difference, ingwa contains calcium, but this one contains silicium and aluminium. Yes.
Okay.
I think that you understand.
Yeah.
Yes.
It's a chemical content. Very different. But on the field, you can confuse that
Yeah,
kind of
because they
products.
are both white and when they cave them, maybe.
Yeah, but I think that there is a small test which you can use. If you have HCl solution, HCl, if you put it on cowling, there is no reaction. But if you put it on lime, there will be what we call in French effervescence.
Yeah.
So you see like something like la mousse. Yeah. I think you understand.
Yeah.
There's a difference between this one and this one. But if you have much lime in your clay, there is a big problem for environment and for the compress the strength of your bricks. Bricks which contain much lime are not strong. But bricks which contain much cowling are very strong, like this one.
Okay.
Yeah. We did a test here.
Okay.
So this skin is only for test. We can command every temperature we want, but not more than 1,280 degrees. So with this kind of kiln, we can go up to 1,280 degrees. And this one is a tool, common tool. This one. It means that first of all, we must have a cuisson lamp. In English, lamp. Slow heat here. But every time after 600 degrees, we can move temperature quickly. That we call it quick heat. You see the diagram here. Slow heat, quick heat, and then we can stabilize temperature for 40 minutes or 1 hour. To stabilize temperature, it's only to help temperature to go through the bricks. Because when you make the fire of the bricks, you are cooking this this surface, but outside. But when you have much time, it means that temperature we have time to go inside bricks. That's why every time we must have 40 or 1 hours with the same temperature, and then we can cool down temperature. That is what I tell you. Every time we take measurement of bricks, and then we must burn it. And after burn it, we must take also measurement to have the shrinkage of the soil. That's what we do here. And also, it will help us to know what is the attitude of soil with all temperatures. Because we can have soil which can be good fired with 850 degrees, but others to fire it you must have more than 1,000 degrees. We have examples here. If you see this kind of bricks, only with 900 we have problems of wax. But with 950, but 900 there is no problem. It means that for this kind of soil, temperature which we must use cannot go over
beyond
900. But this kind of bricks, it's the same color. You see, if you see this kind of bricks, you see that at on 1,000 degrees, it was not good. 1,050, okay, but less than 1,000, it was a bad brick. You can see there is many samples. This is 950. I don't know. This is 900. But if you make test of this kind of bricks, you see that this kind of bricks are not very strong. But if you make you make the firing at 1,050, you see that bricks, they are good bricks. The problem is the mineralogical content of this kind of bricks. This kind of bricks contain much kaolin, but this kind contain much lime. Yes. And you see that this kind of bricks are very strong when it's well done, but this kind of bricks, even when well done, we can have small problems. That's why we can advise to entrepreneurs to mix this kind of soil with sand or kaolin, so we can make it very strong. So we have many tests here. This is a factory plate. Yeah, a factory plate.
It's a stone.
Yeah, to make this one, we must use kaolin and dolomite.
Do you have kaolin in Rwanda?
Huh?
Do you have kaolin?
In Rwanda we have many kaolin. Yeah, even when you are going at Ngororero, you are going at Rusizi, everywhere. This is I don't know, hydraulic machine. Yeah, compressor. So when you know the force, the strength, I don't know, force in English, strength of your bricks, you can know where you can use your bricks. Because good bricks can be used outside and everywhere. Bad bricks can be used only inside. You understand? Because good bricks can support high weight, but bad bricks cannot support high weight. It means that good bricks it's more than 7 megapascal. You understand? Yeah. And this kind of machine can
test.
This kind of machine will give us all the strength And after that, using the stress and the surface, we can have the compressive stress. You understand? Yeah. What to say la compression, la contrainte admissible. I don't know what I can call it in English. Contrainte admissible. Contrainte. La contrainte admissible par la.
Oh, ça fait du bien.
Hein?
C'est fait bien ça.
Yes, when you have the compressive trap, you know the weight which can support your brick. Yeah, that is a contrainte admissible. The force which can support your brick. Yeah.
Yes.
Yeah, I think. Yeah. So here we got this kind of test. Also, we do also the water absorption, because you know we have here in our countries we have many bricks, but you build your house, and after 1 year you will see that your bricks are as problems. Depend upon the water absorption. So we must know the water absorption, so we can advise you to use the bricks outside. Outside means that we have contact with water, or inside no contact with water. You understand?
Yes.
So there is international standard of water absorption. I think the maximum of water absorption for bricks it's 20%. And for tiles it's 12%. You understand?
Yeah.
So if you have more than 20%, it's not a brick. But if you have 20%, okay, it's going to come a brick. But more than 20, oh, you must I think forget that brick and try to find another one. That's why this kind of test, I think it's okay. Also, we make a dimension test because there are Rwandan standards for dimension and also facing. The 4 tests help us to brand bricks. We can tell that this bricks is A category, B category, C category, and unclassified. Yes, because they also unclassified bricks. You know, you can have your bricks and with your hands you can drop it. So that is unclassified bricks. But it's okay, no problem. I don't know how I can show because I don't have any bricks, which is okay. But no problem. Sorry. Okay, let me take this one. So first of all, your surface must be, I think, plan. Surface plan. I don't know anything in English. So here we must block the stress. Yeah. And then 0. Only to do like that. You can jump like that. If you see here,
it's going up.
It's going up. When the brick will be broken, the black will go down. It means that. Even if I continue, see, and then I can read
the weight,
the force.
That's kind of easy.
Force. Yeah. You understand? And when I have the force, I have the surface.
2.5.
I can calculate the stress. It's okay?
Where did you find the strong breeze
in Rwanda?
Yeah.
Oh, there is many. Strong breeze depend upon the firing. Depend upon the type of clay. So here in Rwanda you can find it at Ruliba. You can find it at Emmanuel. Emmanuel, it's Kichukiro, Rugende, I don't know. Paul, Emmanuel Kichukiro, it's Rugende, voilà. Rugende, and here near school. There are also good bricks.
But
Kevin is Kevin is Emmanuel is Uganda. Kevin is Gahanga. Yes, Gahanga. Gahanga.
You have the cost of the road closed.
200.
200.
1,000.
If you can have 200 or 400, it depends upon also the surface of bricks. You understand?
1,000.
To have the compressive strength, you must have the force and the surface. Because force to surface can give us strength.
The best one is 8,100.
This machine can go up to 8,000. Okay, but good bricks.
The best one.
Here, so I can't tell about good bricks here because I must know all the surface. That is I tell you. Must have the surface and the force. Force only, there is no conclusion. Surface only, no conclusion. Surface and force, okay, good conclusion. You can know the good and the bad bricks.
Okay.
Because let me show you. For this kind of bricks, there is a surface. This is the first. You see? But this kind of bricks, see the first is very small.
Yeah.
It means that you can have 200 for this kind of bricks and 300 of this kind of bricks, but this kind of bricks are very good more than this one. Yeah.
How about testing water absorption?
Water absorption. What we do, we take the weight before putting it, before we put it in the water, and after we take also the weight. And when we compare that weight, two weights, we can find the water absorption. You know that? Yes, and we put it in the water 24 hours.
Oh, the whole day.
Yes. But there is another tool which we can use. I don't know. It's bouillard in English. But for that kind of tool, we can use only 5 hours. Yeah. I don't know if we can find it in Rwanda. I don't know. But I think it's Saint Joseph or another place we can find it. I don't know. But here we do only simple tests.
Yeah.
So outside, the place which is available here. Now we have no available place. That's why we can sell it. But after selling, I think 50,000, I think that we will stop selling it. Because, yes, because this one is like a bricks bank. Yeah. So if we go to an entrepreneur to make a amount of bricks, and you see that he's not able to produce bricks on the his machine has some problem. No, the entrepreneurs can contact our office, our coordinator, so they can make an arrangement how to make it. So you can tell you, go and take some bricks at BMC, and then after I will bring back bricks to BMC. That's why we call it bricks bank. It's like a guarantee for entrepreneurs. So here we have many categories of bricks. Many categories from many places. This is from Kevin Kichikiro. Kevin, I don't know if it's Kevin Kichikiro, near Nabarong. Gahanga, yes, Gahanga. How much? How much? But for free.
30 is the price of normal bricks. 35.
Yeah. You know that normal bricks are unclassified for us.
uburyo yubakishwa n'imbere.
Very expensive because here in Rwanda we have only I think 2 or 1 cement industry. But bricks okay, now we can have more than 10 or I don't know 15 brick factories. Understand? So here here we show only that if you use a roll-up bricks for your house, you will use the cost of your wall up to 5%. You understand? You can understand
What about the strength of the wall?
the strength of the wall. Yes, good question. The strength of the wall depend upon the strength of the bricks and the strength of the mortar.
Daniel is calling me from the other side. So just 10 minutes to finish this.
Yes, I think that we are going to finish in 5 minutes.
Yeah, great.
Yes. So
Move away
this
from
wall
so we take
is very strong, more than this one. Yeah. Because for this kind of walls, we can go up to 3 levels or 5. But this one can go up to, I don't know, 10 or 20, I don't know. You understand? Even this terrace. But this one, right now it's 5. 5 levels.
5 stories.
Okay? So, let us show you something like slab. Slab.
Munguni hano bashyiraho.
gusa wabura utara n'igifoto biragaragara nabi.
Timer. You must not. Okay? Huh? That's why.
Mattia! Mattia, wabibonye ma?
Ntegereje amatafari.
If you compare it to ours, and I think that this is a Max Pan slab,
Okay.
Dala Nordi.
Max Pan.
Max Pan. That is Max Pan slab.
This is what Daniel was showing us during the public lecture.
Iyi niyo nshaka.
Reka ndebe ni ibintu biri kubereka ibindi ntacyo ubona gihari.
Guys, come here to see this lab that you never seen it. No,
How cheap?
How is it cheap?
Is I think that if you compare this one and the RC slab, this one is cheapest, the cheapest. How? Because we use less iron, we use less cement and less sand.
Bijyamo hano sima gusa ibyuma bijya muri utu tuntuza.
Oh yeah? No iron there. Iron
How they
here
are
only.
connected? Can you?
And if you want, you can put it inside. No problem, but it's only here.
What's under this bricks?
And this, you can see, you can come and see. Nothing.
Another bricks.
No, no.
Is this
This is the max pan. The same. This one is go up here.
Oh,
Then how
they are connected?
Connected to.
all those
So we have some what you call I don't know the technical word. So we have this color and this one. So we put max band on this column
Question.
because max band is like right. Max band is like this. See? So you put this one
Okay. On this.
on this one. Yes.
and the bricks.
No bricks. This is max band. No bricks.
Yeah, this is max pan.
it's
This is
not
max band.
bricks.
Not bricks.
Oh, it's a kind of bricks.
It's the same material.
Question.
But for max band, we use clay also to make max band, but special clay. In max band, it must have sound because max band must be very strong. Yeah, strong and some covering.
Question. Can you compare the cost for these 3 slabs per meter square each?
Right now there is no calculation, but I think after 1 month we'll have it. So next year.
This is the cheapest.
So if you come here, next year, you will see it. It means that 2080. Yeah. Here, and we have also some manual machines for bricks makers.
Let's go there and take a pictures all together in
Yeah.
front of the machine.